In today's session of Mech Minutes, we demystify another topic related to linear guides, accuracy grades. When designing with linear guides, it is important to select the correct accuracy grade for your application requirements. In this video, we will break down the accuracy standards of linear guides. But first, be sure to catch up on the first 2 episodes of the Linear Motion series. We will begin this lesson by discussing the physical areas of the linear guide, which are defined by an accuracy grade. The surfaces of a linear guide, which are ground to meet specs of an accuracy grade, are referred to as datum surfaces. The datum side of a linear guide can be found by looking at the underside of the guide and looking for the line marks that represent the datum side. The accuracy specifications that are guaranteed by a linear guide's accuracy grade are defined by the vertical datum surfaces A and C and the horizontal datum surfaces B and D. The first set of specifications describe the dimensional tolerances of linear guides. Standard grade guides have a looser dimensional tolerance than high grade guides for the height and W2 dimensions. The next specification describes the dimensional variation for linear blocks on the same rail assembly. The difference between height and W2 dimensions will be within a smaller margin for a high-grade linear guide than a standard grade guide. Selection of an accuracy grade based on the specifications describing dimensional tolerances will affect the tilt of the mounted components, as well as how evenly the load will be shared by the linear guides. We now reach the most important accuracy specification for a linear guide: running parallelism. The running parallelism specification sets a limit for the maximum deviation of the block datum surface to the corresponding rail datum surface over a given rail length. As the block travels along the rail, the microscopic imperfections of the ball raceway grinding will cause minute tilting or rocking of the block in the horizontal and vertical directions. The running parallelism will be listed in the maximum allowable variance between the datum surfaces with the value dependent on the accuracy grade. Combined with the accuracy of the mounting surfaces, this spec will determine the running accuracy of the machine. One specification that is not covered by any accuracy grade is straightness of the rail. A specific rail straightness is not guaranteed and is dependent on the user's base reference edge. The rail should be secured up against the well-machined straight reference edge in order to conform the rail to the desired level of straightness. We have now covered all of the specifications that are defined by a linear guide's accuracy grade. We hope you enjoyed the 3rd episode of our Linear Motion series. For the next episode, we will discuss preload and rigidity. Thank you for watching.